Jet engines and atomic bombs were two of the most revolutionary technologies to emerge from the Second World War. In combination, a jet bomber able to fly at high speed and great altitude could evade any existing defences and thus eliminate any target with impunity. This view on the invincibility of bombers was boosted by the fact that in the straight-wing era, large jet bombers actually had better high-altitude performance than jet fighters. But there were those who harboured nagging doubts as to whether that performance advantage was truly sustainable. If, or rather when, interceptors matched or exceeded the bomber's performance, the deterrent would instantly be in doubt. During the Second World War, the US had relied on escort fighters to protect their bomber streams, culminating in the outstanding P-51D Mustang. The same approach was in their plans for the jet age, but producing a practical fighter with the required 3,000-mile range and sufficient performance to actually defend the bomber proved quite tricky. Some far-sighted individuals had anticipated this issue as early as May 1945. Their idea was to tow jet fighters like a glider behind bombers until they reached the combat zone. The fighters would then be cut free, start their engines, and engage in combat. When combat was over, the fighters would relink to the bombers for the tow back home. A P-80A Shooting Star was transferred to Wright Field to test the idea's feasibility. A cable tow attachment bar was installed in its nose. It could be engaged or released by the pilot and provided both a tow and electrical power. This was critical to run the radio and, most importantly, the heater. Several tests were carried out in which the aircraft was towed behind a B-29. On September 23, 1947, Lieutenant Colonel Pat Fleming took off and attempted to link up in mid-air to the B-29 tow cable. After several attempts were frustrated by air turbulence from the B-29, he finally succeeded in linking up to the end of the tow cable. He was then towed through the air for 10 minutes. Unfortunately, when it came time to unhook, the tow bar refused to release. Fleming eventually manoeuvred underneath the B-29, where the bomber's bow waves snapped the attachment point backwards, blocking his forward view. He managed to land safely, but the program was immediately terminated as being impractical. His aircraft was eventually repaired, restored to standard P-80A configuration, and returned to active service. Although the towed fighter concept died in the US with the P-80A trial, the general idea of producing an escort fighter that could be carried by heavy aircraft was very much alive there. I'll come back to those ideas later, but I want to stay on towed fighters for just a bit longer. Because the Soviets didn't need or produce strategic bombers during the Great Patriotic War, the Politburo was forced to instigate a crash program to develop one alongside their atomic bomb project. The most expedient method to do this was to copy the B-29, resulting in the Tu-4 Bull. As it entered service, they knew that the Bull was very vulnerable to jet fighter attack. They, too, lacked escort fighters with anything like the range to accompany the Bulls to their targets. Although they made vague attempts to design such aircraft, and actually deployed a few squadrons of the long-range MiG-15 SS, true escort fighters remained only on paper. So in 1950, the Long Range Aviation Headquarters set about identifying ways of providing close protection to bombers, and they soon arrived at a towed fighter concept. The resulting project was called BURLAKI, after the teams of strongmen that pulled river barges with ropes in 19th century Russia. The system was a bit more sophisticated than the US one. A drogue was deployed by the Bull on a cable that ran inside an external conduit on the bomber's port side and connected to a winch. The cable was operated by the tail gunner. The MiG-15 had a pneumatically actuated telescopic probe with a barbed tip installed on the center line of its nose. This could mate with the drogue to form a secure attachment. To use it, the bomber paid out about 300 feet of cable behind it. The fighter pilot maneuvered to get the probe into the drogue and then fired the barbed probe into it. He could then turn the engine off. When enemy fighters appeared, he would separate from the drogue, engage them, and then return based on transmissions from the bomber's radio and the MiG's direction finder. Simple. The system was tested using the Yak-25 fighter prototype and a B-25 Mitchell. 9 successful contacts were made between June and September 1950. Development then moved on to the Faggot and Bull combination in February 1951. Again, the coupling system worked flawlessly and it passed state acceptance trials by August. But other unrelated issues emerged that doomed the project. First, the Bull's speed was adversely affected by pulling the MiG, knocking maybe 50 miles an hour off the top speed and thus slowing the entire formation. Second, and arguably more serious, was the impact on the MiG's pilot. Although the fighter's engine was easy enough to stop and start in flight, when it was off, the aircraft had no electrical power, and thus the cabin heater didn't function. This led to him getting very cold in the high-altitude air. Because cabin pressurization was also run electrically off the engine-driven generator, the pilot also had to wear an oxygen mask for extended periods, which was very uncomfortable. Further trials were performed with another 5 modified aircraft to establish whether the system would be practical for the forthcoming Tu-95 and Tu-16 bombers. These included tactical trials in which the fighters were tasked with defending their charges against other MiGs that acted as enemy interceptors. In the first run of the scenario, the bombers spotted the enemy fighters and attempted to release their own fighters. This unfortunately took too long, and the interceptors made 2 firing passes, destroying the bombers and the defending fighters. In the second run of the test, the defending aircraft took turns flying combat air patrols around the bomber formation. Although this did increase spotting range and allowed the defenders to release earlier, there was still not enough time for them to get into a good defensive position. Their fuel was also very depleted in the process. Thoughts of fitting a search radar to the bombers were dismissed as speed and electronic countermeasures were regarded as better defensive measures. The US, however, had several more good ideas up their sleeves. During the 1930s, the US Navy had deployed a handful of Curtiss Sparrowhawks to the airships USS Akron and USS Macon. Their intention was to create a sort of flying aircraft carrier that could scout for the battle fleet. Akron crashed in 1933 and Macon in 1934, ending that line of experimentation. Some aspects of the design remained in the minds of the aircraft designers, though. Most prominent was the use of a trapeze to move the Sparrowhawks clear of the airship and then recover them by means of a strong hook that caught the fighter as it maneuvered onto the end of the frame. There was also a clear advantage in doing away with the fighter's landing gear. These were removed aboard the airships and could be replaced with fuel tanks, increasing range by 30%. As more evidence came in from Europe about the vulnerability of bombers to fighters during daylight operations, the need for an escort fighter able to escort super heavy bombers was revived, and a project began in April 1941 to find such an aircraft. 18 months were spent fruitlessly trying to design around the problem of building a fighter-class aircraft with 30-hour endurance. No obvious solution was presented, and even if the issues of range could be worked through, the problem of human endurance remained. Project MX-472 was then initiated in December 1942 to find an alternative. The team initially experimented with ramjet-powered drones before deciding that what was really needed was an aircraft that could be stored inside the bomber and then released when it came close to the target area. The McDonnell Company of St. Louis, Missouri were the beneficiaries of several of these high-concept projects in the second half of the war, principally because they only had a limited amount of critical war work to distract them. For this reason, they were also early pioneers of jet fighters, most notably the FH-1 Phantom carrier fighter. Late in 1944, they came to the MX-472 project team with their Model 27E, a tiny, low-winged monoplane with a unique X-shaped tail and a swept wing that folded for storage. It was powered by a single Westinghouse turbojet. It was so small that it could actually be stowed in either the number 1 or the number 4 bomb bay of the forthcoming B-36 intercontinental bomber. That meant that it was limited to 15 feet in length and 5.5 feet in fuselage diameter. McDonnell's design was 14 feet 9 3/4 inches long, with a maximum width of 4 feet and 2 inches. To simplify wing folding, all of the equipment the fighter needed was stowed in the fuselage, which was 6.5 feet tall at its tallest point. The 3,000-pound Force J34WE22 engine was pulled as far forward as possible in the fuselage to maximize the distance between the center of gravity and the tail surfaces. A 4-foot 4-inch long tailpipe extension carried the jet exhaust through the fuselage. It was wrapped in an insulating blanket to prevent things getting too hot. Air diverted from the intake duct provided additional cooling. 115 gallons of fuel was held in a horseshoe-shaped tank located under the compressor section of the engine. Fuel pumping was electric, as was the skyhook, which was adapted from the system used on Akron and Macon. It folded out from the fighter's nose, coming to rest at a point 2 inches forward of the center of gravity and 5 feet above it. In the case of an electrical fault, the hook could be retracted using pneumatic pressure from the gun firing circuit. Those guns were 450 caliber M3 Brownings with 300 rounds per gun. That was comparable armament to the P-80 Shooting Star, but it was quite light in comparison to the cannon-armed aircraft that were being fielded in other countries. The guns were aimed with the common K-14 gun sight. To maintain the all-important center of gravity position, spent cases were retained in an empty bay in the fuselage. Inevitably, there had to be other compromises to fit all of this kit into such a small aircraft. The most obvious one is the size of the cockpit, which is literally half the volume of a contemporary fighter like a Mustang. Pilots had to be a maximum of 5 feet 8 inches tall and weigh less than 200 pounds when carrying all their gear. To save space, many instruments were deleted from the cockpit and the rudder pedals were adjustable, but the seat wasn't. That seat was inclined at 33 degrees, which actually had the side benefit of increased G resistance for the pilot. A small panel of steel armor was provided to protect the pilot's back, head, and neck, but in truth the little fighter was not likely to resist many hits, being so tightly packed. Because of the altitude at which the bombers would fly, and thus the aircraft would fight, the cockpit was pressurized using bleed air from the engine compressor. Cabin heating was provided from the same source. In the event of an emergency, there was a rudimentary ejection system that boosted the pilot's seat out using a powder charge. I'm not sure I'd have fancied that, but each to their own. Wings were aluminium, and they could fold right up alongside the fuselage. They had flaps on the leading edges to improve low-speed control, and there was a safety system on the skyhook that prevented the aircraft being dropped unless the wings were fully extended and locked. The X-shaped tail incorporated the functions of both the rudders and the elevators in a very compact arrangement. The fixed fins are for additional stability on what is an inherently unstable overall configuration. There was a single speed brake beneath the fuselage, the effectiveness of which we'll come to in a bit. Common with some other aircraft of the era, it had a max switch that automatically extended that brake as the maximum controllable speed was reached. Hopefully you're getting a sense of how well thought out and engineered the XF-85 was. The contract for its construction was signed in June 1946, covering 2 stripped-out prototypes. There was then a more comprehensive contract covering fully featured prototypes in February 1947. While the prototypes were being built, tests were conducted with the F-18 Shooting Star and a B-29. Initial approaches were flown with the Super Fortress flying at 225 miles an hour. Remarkably, the F-80s were able to approach within 6 feet of the bomber, even if it had its bomb bay doors open. There was some buffeting and the fighter was quite close to its stall speed, but it wasn't too bad. Things could be improved by feathering the inboard engine propellers of the Super Fortress and docking with the aft bomb bay. These measures served to keep the incoming fighter away from both turbulence and the spinning blades of death. The F-80 was, however, a conventional fighter and quite a good one aerodynamically speaking. It was essentially impossible to predict how the somewhat radical XF-85 would perform in normal flight, let alone in the turbulence behind a B-36. Wind tunnel testing was therefore scheduled. Unfortunately, as the fighter was lifted up onto the test rig on its skyhook, the hook abruptly detached, and the fighter dropped to the floor, crushing the nose and requiring a month of repairs. By the spring of 1948, though, the tests were sufficiently complete as to make judgments about performance. The major issues related to the skyhook, which had a dreadful effect on horizontal stability when it was deployed. And by dreadful, I mean that it reduced stability by 75%. A ventral fin was therefore added to improve matters. The leading edge flaps turned out to do nothing very much, which was a surprise to McDonnell as they had worked well on the scale models. The brake too was relatively ineffective. The contract for the first phase of flight tests had been signed by this point. There was a snag though. No B-36 was available for the tests, so McDonnell was loaned a B-29, or more precisely an EB-29 as it was now on bail to McDonnell. The aircraft was nicknamed Monstro, and it was fitted with an adapted version of the trapeze plan for the B-36. Monstro itself was subject to fairly significant modifications alongside the trapeze. All of the bomb racks were removed, as was the tunnel in the rear bay and the radar equipment under the wing root. The front bay was extended 30 inches forward and a fairing installed ahead of it to deflect air around the XF-85 and thus prevent its turbine being turned by the airflow while it was stowed. For the test program, the trapeze was supplemented by a metal bracket, which the test team called the horse collar. It could be lowered onto the fighter's nose to stabilize it if required. Most of the equipment that ran the trapeze was in the front bomb bay, and the trapeze itself was in the rear one, along with the connectors for power and oxygen that connected the XF-85 to the mothership. Amongst the many modifications were some subtle ones. For example, the B-29's radio antenna was on top of the fuselage, and was therefore masked when the XF-85 approached the underside of the aircraft for docking. Another ventral antenna was thus installed. Because locating the bomber after a sortie had already been identified as an issue, Monstro was painted in a garish colour scheme in which the entire aft section was bright yellow, with diagonal yellow and black stripes on the wingtips and horizontal stabilizers. An M16 smoke bomb was also carried for emergencies. Operational bombers would have also had smoke generators like those used by skywriters and a radio beacon. All up, Monstro weighed 112,600 pounds at takeoff, which was well within the Superfortress's capability set. By January 1948, everything was ready to go, but there was a 6-month wait until the XF-85 itself was completed. In the meantime, a special loading pit had to be built at Murrock to allow the XF-85 to be lifted up into the bomb bay. There was unfortunately insufficient clearance under Monstro to allow that to be done from the runway. Captive flights came first, beginning in July 1948, with the XF-85, now more commonly known as the Goblin, being lowered into the slipstream to see what happened. Even this required a pilot. Only Ed Schock, one of McDonnell's test pilots, ever flew the XF-85. He sat in the XF-85 while it sat in the slipstream trying out the controls. Then he progressed to switching the engine on and moving it around a little within the constraints of the skyhook. On at least one occasion, the horse collar was required to stabilize the little fighter as oscillations developed, threatening to detach it from the trapeze. The first free flight came on the 23rd of August. It was made at 20,000 feet and 200 miles an hour, and it went pretty well. The Goblin launched okay. In flight, Schock's view was that the Goblin had excellent lateral stability, good directional stability and control, and reasonable longitudinal stability. One immediate issue he discovered was that the aircraft had insufficient trim capability, meaning that he had to constantly pull on the stick to maintain level flight. Even so, the fact that McDonnell, still a young company, had managed to engineer something as unique as the Goblin in only 4 years is quite remarkable. After 10 minutes, Schock attempted to dock back on Monstro. Things now took a turn for the worse. His first attempt was unsuccessful, as the need to constantly pull back on the stick while adjusting the throttle made the fine control required in a low closure speed approach just too hard to administer. So he decided to go around again and come in with the throttle further advanced and maintain a more consistent position thereafter. This, unfortunately, led to a rather higher closure speed than before. The skyhook hit the trapeze too far back to engage. The Goblin then bounced up into the horse collar, causing the trapeze bar to strike the canopy. This shattered, knocking Schock's helmet off. The XF-85 fell away, but Schock was able to retain control after losing a few thousand feet of altitude and probably gaining a few grey hairs. Assessing that the Goblin was relatively undamaged, he decided to land on the desert floor rather than trying another approach. Although the XF-85 had no landing gear, it did have a basic landing skid for just such situations. Schock managed to put the aircraft down, and despite its quite high 140-mile-an-hour landing speed, additional damage was minimal. Modifications were then made to fix the trim authority issue by allowing the ruddervator to deflect about 70% more. A trim spring was also added to the control stick to eliminate the need to constantly apply back pressure. The second free flight was thus delayed until October. After one failed attempt to hook back up to Monstro, caused by shock anticipating contact with the trapeze and instinctively nosing the Goblin down to engage the bar, he was successful at the second attempt. Although this raised hope for the system, further flights demonstrated that it had likely been a fluke. The dynamics of the process were very complex because of the shifting turbulence generated by the trapeze, Monstro's fuselage and its wings, and the Goblin's small control surfaces. Success in the operation required a high level of pilot skill and a fair slice of luck. In 3 of the 7 flights the Goblin took in testing, Shock had to land in the desert. Doing this consistently in a combat zone after a long flight, potentially in the dark or bad weather, was probably unrealistic. The Goblin itself was actually a remarkably effective fighter. It weighed 3,984 pounds empty and 5,600 at full load. It was therefore less than half the empty weight and a third of the loaded weight of an F-80 Shooting Star. Maximum speed at 40,000 feet was 573 miles an hour, and it could hit 648 at sea level. It was unlikely that a Goblin would ever get down that low, but even so. Climb rate at sea level was 12,500 feet a minute. Those are great numbers for the time. It was 50 miles an hour faster than the Shooting Star, and it climbed twice as fast. In fact, its numbers are only marginally different to the MiG-15. Combat mission duration was only about 20 minutes at 40,000 feet, but it could patrol for an hour. It wasn't just the challenges of reattaching to the trapeze that killed the Goblin, though. In 1947, the USAF had been introduced to another concept that appeared to offer greater promise. Amongst the German scientists who had come to the US in Operation Paperclip were Bernhard Hohmann and Dr. Richard Vogt. The latter had been the chief engineer at Blohm & Voss. Between them, they had either been involved in, or at least directly observed, experiments conducted by the German Glider Institute during 1944, in which 2 Clem KL-35s were attached at the wingtips to see if this combination led to performance improvements. Inspired by the results, the 2 German engineers developed a similar concept in which smaller aircraft, could be fighters, but could also be winged fuel tanks, could be attached to a bomber's wingtips in order to increase wingspan. This would create a more efficient, higher aspect wing, enabling the 2 Parasite aircraft to be carried with almost no drag penalty. Vogt called it the floating wingtip. Application to the bomber escort problem was obvious to everyone. Small-scale experiments were conducted at Wright Field using a C-47 and a Culver Q-14B to test the general feasibility of the concept. A simple apparatus was used at this stage. The C-47 had a small ring attached to its wingtip. The Q-14 had a backwards-facing lance, and its pilot maneuvered to place the lance into the ring. Once connected, air pressure kept the 2 aircraft locked together. To uncouple, the Q-14 pilot increased his airspeed and could thus fly out of contact. Based on this relative success, Project Tiptoe began in 1950. It was decided that a vastly more sophisticated and mechanical system was needed for an operational system. Republic Aviation were contracted to design it and to modify a pair of F-84 Thunderjets and a B-29 for trials. The new coupling mechanism involved a short, hydraulically controlled boom being extended from the B-29's wingtip. The F-84s had a small, forward-pointed lance on one of their wingtips. The pilots flew their aircraft so that the lance connected to the boom in similar fashion to a probe and drogue refueling setup. Once the lance was in the receptacle, the boom was retracted, drawing the wingtips back together, whereupon a pin on the B-29 wingtip extended and locked the aircraft together. A rubber seal on the B-29 side ensured that air couldn't enter the gap and cause aerodynamic havoc. Once attached, the F-84 pilot could power down, although the engine turbine would windmill in the airflow. Although complicated, the system initially seemed to work well. The main issue with the whole arrangement was that the B-29's long wings flexed quite a lot more than those of the C-47. Fighters on the wingtips tended to flap up and down with uncomfortable amplitude. Although they could somewhat control this flapping using their ailerons, sometimes the oscillations after connection got so bad that the F-84 pilots had to get away in a hurry to prevent a disaster. This could be accomplished using explosive bolts in the event of a real emergency. The need to constantly control all 3 planes was the most significant overall problem with the concept. The idea, after all, was to reduce pilot fatigue, but in fact it probably multiplied it. As a result, after the successful completion of the first test cycle, Republic were issued with a follow-on contract to develop an automatic flight control system. Test flights of this began in March 1953 and they initially went fine. But on April the 24th, disaster struck. Another problem that had been encountered throughout testing was that of getting reliable power from the Super Fortress to the Thunderjets. On April the 24th, the trio had been flying for a little while when the F-84s decided to swap sides. The right-hand Thunderjet detached first, and then the left, flown by Major John Davis, did the same, and then he hooked up to the right wing. His instruments told him that he was receiving power, so he shut down his engine and he switched on the automatic control. But the power was not in fact on. The F-84 suddenly began pitching very violently. It flapped up and around and hit the B-29's wing. The Thunderjet's nose was sheared off in the impact and the B-29's wing was wrecked. Both aircraft plunged into Peconic Bay. Davis and all 5 aboard the B-29 were killed. Major Clarence Bud Anderson, flying the right-hand F-84, was the only survivor. Unsurprisingly, this led to the immediate termination of Tiptoe. There were, however, 2 follow-on programs of sorts. Chronologically, the next attempt at a Parasite fighter was the FICON, or Fighter Conveyor Project, which began in 1951. Rather than an attempt at fighter escort, the idea in this case was for the B-36 to carry an F-84E close to the target, whereupon the fighter bomber would be released. The smaller aircraft would race in and deliver its atomic bomb before returning to the mothership. FICON did away with the wingtip connection and returned to a trapeze, albeit a rather differently designed one to that used in the Goblin. The new trapeze incorporated some elements of Tiptoe in that it had a lance and receiver arrangement at the front end. Once the lance was docked, the locking pins on the yoke straddling the Thunderjet's forward fuselage slid in and secured the fighter. It could then be partially drawn up into the bomb bay. I say partially because the size of the F-84 meant that only the cockpit, fuselage spine and tail fin actually fit up into the bomb bay. The resulting drag reduced the B-36's range by as much as 10%. The pilot was able to leave his cockpit once in the bomb bay, though, which would have drastically reduced his fatigue levels on a 10-hour mission. FICON trials started in January 1952, with the first successful hookup on the 9th. Issues with turbulence that required some adjustments meant that the F-84 wasn't successfully drawn up into the bomb bay until late April. 170 successful launches and recoveries were made in 1953. From May, these used the swept-wing F-84F Thunderstreak instead of the straight-winged E. While testing was underway, the mission profile changed from nuclear bombing to reconnaissance. The theory was that the smaller, faster RF-84F would be able to access heavily defended targets more readily than a large platform. The bomber would loiter well outside the defensive perimeter to recover the Thunderflash on its way out. Testing went sufficiently well that 10 RB-36Ds were converted into motherships, designated GRD-36D. 25 RF-84K Thunderflashes were also ordered. These had the retractable lance for connection to the trapeze in their nose and tailplanes with increased anhedral to allow them to tuck up more tightly inside the bomb bay. Remarkably, the combination did see some operational use in 1955 and 56, although the US wasn't involved in any major conflicts at the time, so there were no combat missions. The major issue with the system in operation was that when the RF-84K was fitted with a drop tank and installed in the bomb bay via the special pit, the GRD-36 had only 6 inches of ground clearance. That made ground handling and takeoffs a rather delicate affair. Convair designed a set of ramps that pushed up the tail of the RB-36 while loading was taking place. It was easier for the aircraft to meet in the air, but that of course added additional complication to any mission. The main killer of this project was the U-2, which was far more survivable against mid-1950s defences than an RF-84 and the obsolete B-36. There was apparently some consideration given to carrying a more advanced aircraft. In this poor-quality scan, the proposals were Skyray, Delta Dagger, Thunder Chief, and apparently Phantom. None of these even reached the paper concept stage, though. In early 1957, the GRD-36s were mothballed and most of the Thunder Flashes were scrapped. That didn't stop yet more proposals emerging. There were lots of B-36s around, and they did have exceptional range on their side. One proposal mated an F-86 Sabre that had been modified into a guided missile with the Peacemaker. Another used it as a launch platform for the very fast but shorter-ranged B-58 Hustler. Later drawings were made of B-36s carrying the ramjet-powered Navajo cruise missile as a Bombay-docked Parasite, or the competing Northrop Boojum on the bomber's back. Again, these never left the drawing board. The last operational test of a B-36-based Parasite concept was Project TomTom, which saw a return to wingtip docking. I assume that this was because of the operational limitations of Bombay docking in terms of range and payload carrying ability. This time, two RF-84Fs docked to the wingtips of a specially modified RB-36F. This began flight testing in 1955 and continued into 56, reaffirming the aerodynamic benefits that the fighter's wings bestowed on the B-36. But the tests were abruptly stopped when one of the RF-84Fs began flapping violently, breaking the aircraft coupling mechanisms in the same manner as Tiptoe. In this case, all aircraft were able to safely land, but the program was terminated before more people were killed. Practically as well, there was no way that a pair of fighter pilots could remain trapped in their cockpits for nearly 40 hours, which was the RB-36's theoretical endurance. That was then the end of Parasite fighter experiments. Although the systems of attaching aircraft to their motherships had their issues, the fundamental problem with the concept of a Parasite fighter was more fundamental. The Luftwaffe during the Battle of Britain and then the mighty 8th Air Force over Germany had discovered at great cost that it was a mistake to tie the escorting fighters too close to the bombers. Fighters were fundamentally an offensive weapon. They needed to roam ahead, sweeping for enemy fighters and even strafing their airfields. The compromises of the various Parasite fighters, with the possible exception of the MiG-15, meant that they were incapable of such action. And the BURLAKI experiments bore out that even a high-performance fighter struggled to get into an advantageous position given the limited warning afforded to a bomber stream about impending fighter attack. The reconnaissance concept was also flawed. What was needed to evade defences was a specialised platform with their extraordinary performance, initially the ability to fly very high, later to fly very fast, and eventually to evade detection through stealth technologies. Being small, like an F-84, was of little practical value in evading even late 1950s defences. So, although it's easy to admire the engineering that went into these aircraft, it's also important to recognise that some logical thinking on the behalf of the defence establishment would have saved a great deal of money and, sadly, several young lives.